This video is to show you how to do the chi-square goodness of fit test in Jamovi. I'm going to use the fruit soda flavors example. So this is what it would look like in a textbook. We would have a little text and the table. The thing is, when we have a data set, we won't have that table. We have to create it. So let's go to Jamovi. I put the problem here just in case we need to look at it. So I don't have the table when I have a data set. I have columns with tons of data. And remember, the goodness of fit is also called one-way chi-square. It's called one way because it's only using one variable. In this case, it's going to be the variable flavor. Notice how it's nominal and it has different levels: cherry, strawberry. So those are the 5 flavors that we were interested in. We want to see whether there's a difference between those 5 flavors. If there is a difference, it might be that one of them is just more popular. And you know this, you could use this to inform, like if you own a store or something like that, you can inform your decisions with that. So to actually do the chi-square, we're going to go into analysis, frequencies, and it's here, goodness of fit. Notice how it's only going to take nominal or ordinal variables. So if you actually try to put in a continuous variable here, it will just not. I don't think it will let you. It will not do it. Flavor, and that's it. That's literally all we have to do here. We have the counts. Let me show you the problem again. So the observes are our counts. And here we have the proportions. But remember, in this problem, we thought we were expecting the same percentages in each category, so we have to check expected counts, and then it puts the 20, 20, 20, 20, 20 in there. You could change this if you wanted to. In this problem, we expected all the categories to be the same, but let's say we didn't. You could change the ratio here. But we don't have to do that right now. And here's our actual chi-square test, and this is going to be our chi-square obtained and our p-value. Okay, let's go over the technology. So we have this table, and this one should look very similar to what we start our problem. It has the categories here, has the observes, the expecteds. You can ask for this column if you want to. You just have to check a little box in Jamovi. But the one that we're really interested in is this one, chi-square goodness of fit. So it gives us the chi-square obtained. That's what this part is. Degrees of freedom and our p-value. So we need that p-value so that we can compare it to the alpha. So 0.001. is actually way smaller than our alpha of 0.05. So we reject null hypothesis. Whenever we reject the null hypothesis, that means we have statistical significance. Now let's go over the conclusion. So we conducted a chi-square goodness of fit. That's what it's called. It has another name, one-way chi-square. This is just what Jamovi calls it, so we can use that. You need to say what the significance level was, so 0.05. So this helps people compare your p-value immediately to that and basically do this in their heads. The next thing we're going to do is have this statement. This one is mostly for me. In a proper paper, you would just say the next sentence, that it was statistically significant. So here we reject the null hypothesis. You need to write that. You're going to say that it was statistically significant. How statistically significant? Well, you use the Ward and nullity table. This table is in your notes, and it classified that p-value as overwhelmingly. So you need to add that little sentence there. And what were we doing? Well, basically we were comparing these 5 categories. The assumption was that they were expected to be the same, like the proportions were the same for all the flavors. But we rejected that null hypothesis. We reject that null hypothesis. So that tells us that actually one of those flavors is it's more popular than the other ones. So there is a preference of flavors among customers. You can eyeball it. You can see this one has more observes, and it kind of decreases throughout the data, the categories in the data. Here we have our symbol for chi-square, our degrees of freedom. This should be our sample size. And then here we have our chi-square obtained. And then finally we have our p-value. This one didn't have the little less than, so we can just put the equal sign in there. That's okay.